Yeah, here you go. Today, we're going to learn about integrals as net change. For anything you'd care to mention, I started the lesson not realizing that we weren't taping, so that's why this is sounding very stilted. Present amount equals initial amount plus the change in the amount. That's true for anything you'd care to mention. I gave the students a couple of lame examples, and now we're going to go on. Okay, great. So, where's my notes? Let f of t be the present amount. Let's say f of t is the present amount. Okay? Now, if f of t is known, if we have an equation for f of t, then we don't have to do any of this stuff, right? If I have an equation for f of t, I just plug in whatever t is and get my answer. Okay? If f of t is known, we don't need the above. We don't need to have this concept of present amount equals initial amount plus change in amount. But what if all we know is not f of t, all we know is the rate of change of the amount? What if all we know is f prime of t, the rate of change of the amount? Okay. Well, let's deal with that situation. Let's do a simple example. Let's deal with position. Your position. Imagine you're on the x-axis. You're going left or right on the x-axis. And we'll let s of t be your position. S of t is your position on the x-axis. Well, your position on the x-axis is going to be equal to your initial position plus the change in the position. Your initial position, I'll call that S naught. And the change in position, we've actually learned the term for the change in position. Do you remember what we call it? It starts with the letter D. Yeah, displacement. This change in position, we call this displacement. Okay? And we call displacement, symbolically with delta S. So how do I find delta S if all I have is, how do I find delta S if all I have is a formula for the rate of change of the position? All I have is S prime of t, which, by the way, what's S prime of t equal to in this case? Well, no. Just generally, if S of t is my position function, what's the derivative of my position function? Yeah, v, velocity. Exactly. So I've got a situation where I want to talk about where I am, but all I have is a formula for my velocity, not a formula for S of t. If I had a formula for S of t, like I said, I'll just stick in various values of t and answer my question. But I don't have a formula for S of t. All I have is v of t. Well, we can still get an expression for delta S. And now we get to do what Leilani was saying. If I want to get an expression for delta S, for the change in my position, but all I have is velocity, what am I going to have to do to this velocity function? Yeah, take the antiderivative. Okay, that is, your displacement is going to be the definite integral from the initial time to whatever final time you're interested in of v of t dt. And let me show you this graphically, kind of as a reminder of what we've been doing. You know, imagine I have a graph of v of t, and this is t in seconds, and this is v of t, let's say meters per second, okay? And I don't care what the units of the what the scaling of the y coordinate is. And let's say I had my velocity versus time graph that's kind of looking like that. And I'm interested in knowing how far I went from the initial time to the final time. What distance did I go? Well, we know that distance equals rate times time, or another way to put that is, you know, what do you call, well, if you're in physics, we go distance equals average velocity times time. Here in calculus land, I guess we'd use S equals v times t, but whatever, if you multiply velocity times time, you get your distance. Velocity is meters per second, time is seconds, multiply them, you get your distance. And if I have a constant velocity, then if I had a constant velocity, then all I'd have to do is get the area of this rectangle, right? Velocity times the time gets you the distance, the area of the rectangle. But I don't have a constant velocity. I've got a velocity that's changing, but as you know, if we get the area between the graph and the time axis of a velocity versus time graph, I'm going to get my displacement. Or another way to think of it is, it's just a lot of little times of going constant velocities. We'll say, okay, I'm going this constant velocity, then I'm going that constant velocity, then that constant velocity, and so on, okay? That constant velocity, that constant velocity, that constant velocity. Then I end up just adding up the rectangles. I'm trying to show you all these different reasons for why it turns out that the area between my velocity versus time graph is going, the area between my velocity versus time graph and the time axis is going to get me my displacement. It's a bunch of little mini velocity times times, which gets me these rectangles, and I add up the rectangles, or whatever. However you want to do it, there it is. That's how you get it. And so I get to say this. Generally, S of t equals S naught plus the integral from t naught to t sub f of v of t dt. And so, generally, this is true for position, but it's really true for any function. It's true for any quantity. F of t equals the initial f plus the integral from the initial time to whatever your final time is of f prime of t dt. And this is what we're going to be working with, just over and over again. Final value equals initial value plus change in value, but the change in value is the integral of the rate of change of that value. Okay, let's do an example of this. When we do a couple of them, you'll see they go pretty well. Okay. Example number one. Get a quick take a walk. A particle moves along the x-axis. According to v of t equals the sine of t for 0 less than or equal to t less than or equal to 2 pi. So I've got a particle moving along the x-axis, but I'm not giving you an equation for where it is. I'm just giving you an equation for the velocity at any time. We got a message. Justin Hamill at the end of the period. So Justin, you need some guidance, I guess. Okay. Let me tell you one more thing. Let S of 0 equal 3. So I don't know an equation for its position, but I do know where it's starting. It's starting at 3. Let's answer several questions, easy questions, culminating in us using that equation. But first, let's do a few easy ones. When is the particle stopped? You tell me, at what times is this particle stopped?
2 pi.
Good, 2 pi. When else?
Pi.
Good, 0 and pi. Good for you. So I just want you to get a sense that this is an equation giving us velocity, not position. So time equals 0, pi, and 2 pi. My particle is momentarily at rest. Great. Let's do number 2. All righty. When is the particle moving to the right? Tell me, during what interval is this particle moving to the right?
0 to pi.
You guys okay, 0 to pi?
Yeah.
Why 0 to pi?
Sine is positive.
Yeah, because the sign of t is positive for those values, like everyone is saying. Good. So from 0 to pi. Not including 0 to pi because there's no momentarily at rest at those times. Okay, great. Here comes the next one. What is the displacement, which, delta s, from t equals 0 to t equal pi? Well, someone tell me, what am I going to have to do to get that displacement?
Take the integral.
Yeah. I'd like everyone to please do that now. You're going to integrate my velocity function. And it's going to have to be from 0 to pi. Hopefully you're getting the negative cosine of pi minus the cosine of 0. No, minus the negative cosine of 0. That's a lot of negatives there. You guys okay that it's 2? Any question or problem on that? Okay, so here comes the big one. What is s of pi? What's my position at time equal pi? I know my displacement is 2. I know I went 2 to the right. What's my position at pi?
Do you want us to answer?
Yeah, sure.
0.
Wrong. My velocity
Oh.
is 0, but not my
I
position.
think so.
What do you say, Kylie? How many people thinking 5? Well, Kylie, how'd you get 5?
Because it said earlier that S naught was 3, so if you add that with delta S.
Beautiful. My initial position was 3, and I went 2 more to the right for a grand total of 5. Yeah. My position at pi is going to be my initial position plus the change in my position. Now, I could do this sort of thing. What distance did I travel from time equals 0 to time equal 2 pi. And I've got a weird situation because my particle's moving to the right and then moving to the left. So these times when the velocity is 0 are quite often turnaround times. It's like when you throw something in the air. If it's going up and then coming down, well, when its speed is momentarily 0, that's when it turns around. Same thing with a car. If your car is accelerating, if your car has a velocity this way, but it's decelerating, so your car slows down, comes to a stop, and then starts going backwards, well, that moment when it came to a stop, that's the turnaround time. And those turnaround times are often the times when the velocity is 0. So these are possible turnaround times. So you tell me, if I want the distance traveled from 0 to 2 pi, what should I probably do?
Find the distance on each of those intervals.
Yeah, good for you. Find the distance on each of those intervals. Get the distance from 0 to pi and add that to the distance from pi to 2 pi. So I would do this. I would have that distance equaling the absolute value of the integral from 0 to pi of v of t dt plus the absolute value of the integral from pi to 2 pi, just to make sure everybody's positive, because I just want distance, and distance is positive. So yeah, I would just go that. Just get how far I went from 0 to pi, which by the way is 2. What do you suppose the distance traveled from pi to 2 pi is going to be?
2.
Yeah, 2 also, because there's symmetry there. So it ends up being a grand total of 4. Okay. Let me see if I want to give you this problem. Just 1 second. Maybe I will. Yeah, sure. But I'm going to I don't think I'll give you all part A, B, and C. I think I'm just going to give you like part D sort of thing. Or maybe, I don't know. Yeah. Oh, yeah. Okay. Here. Particle moves along, this is example number 2, and then we'll declare ourselves done. Particle moves along x-axis, but all I've got is an equation for the velocity. And this is going to be true from 0 to 5 seconds. And S of 0 equals 5. So I'm telling you my initial position is 5. Or maybe I want to be tricky about it. Yeah, let's be tricky about it. Here. Trickiness. S of 1 equals 5. Yeah, S of 1 equals 5. I'm going to ask one question. Find the position at time equal 5. Good luck. Find the position at time equal 5. I'm really short-circuiting this part of the problem, but we'll see if you get it. I'll give you a hint. S of t equals S naught plus the integral from t naught to t of v of t dt. But in this case, what's my initial, what am I going to have to put here for S not my initial position? S of what? Yeah, it ends up being S of 1. This is S of 1. So what's this integral going to have to be from what to 5? Yeah, from 1 to 5. Okay, now you guys do the rest. Ooh. Is anyone doing it by just using their calculator? Function integral x squared minus 4 comma x comma 1 comma 5. Anyone doing that? Well, be my guest. Is anyone getting that answer? Yay. Good for you, Justin. Yeah, and I have to confess, I just did this on my graphing calculator, you know. And I'll tell you right now, Chapter 7 is a yes calculator exam. You'll be able to use your calculator on all of the Chapter 7 exam. All right, so, by the way, we've only got a couple minutes left, but we could actually get an expression for S of t, couldn't we? We could get an expression for S of t. What would you have me do? Like, all we know is v of t. We know v of t equals t squared minus 4, but I wanted to get an expression for the formula for the position. What would you have me do?
Take the antiderivative.
Yeah, good. Take the antiderivative of both sides, right? So this time, here I get s of t, and here I get 1/3 t to the third minus 4t. But what else am I going to have to include on the right side of this equal sign?
Plus C.
Yeah, plus c. And now we're going to go ahead and get c. And the way you're going to get c, you tell me, how am I going to get c? Yeah, good for you. Plug in a 1 and a 5 for s of t. So s of 1 is going to equal 5, which is equal to 1/3 times 1 to the third power minus 4 times 1 plus c. So I end up with, what is that, 9, 8 2/3? 8 2/3 equals c. So s of t is going to be 1/3 t to the third minus 4t plus 8 2/3. So there you go. Now sometimes you can't get an expression for s of t because they don't even give you an expression for v of t. They'll just give you a graph of v of t and say, hey, just work with the graph, and we don't even know what the formula of v of t is. Or they'll give you a table of values for v of t, and they'll say, hey, just work with the table of values. And then you won't even be able to get an expression for s of t. But you can still always get what s of t at certain points are just by using this. So what did we learn today? Integrals are net change. If they give you a rate equation, integrate it to find the change in whatever the value is. Thanks a lot.